Hi everyone, it's Miss Haley again, and today, in today's video, I'm going to be going over the 4.5.1 study guide for Algebra 2. So let's go ahead and get started on that. So here is the 4.5.1 study guide. Hopefully you've already had a chance to complete this and you're just checking your answers with me, or maybe you've printed it out and you're going to do it together with me. Either way, do whatever helps you best. So this week we're looking at stretching functions vertically. Last week we did a transformation on functions, shifting them vertically and horizontally. And so this is just another transformation that you can do on a function. So let's go ahead and look into that. So the main idea, when you stretch or compress a function, you change the shape of its graph. So if you remember last week when we shift functions left and right or up and down, so horizontally or vertically, only the position of the graph changes. The shape of the graph does not change. So when we're looking at stretching graphs, that's when the actual shape of the graph changes. So for example, if we're looking at the normal parabola x squared, if we were to stretch the parabola, it would get skinnier. And if we were to compress the parabola, it would get wider. Okay, so that's what stretching and compressing means. So now let's look at some more details when it comes to stretching and compressing. Okay, so when we stretch vertically, the graph moves away from the x-axis. Okay, so when we're looking at this transformation right here, when we're stretching vertically, it's going towards the y-axis and further away from the x-axis, right? Because the sides are kind of lifting up. So that's how the graph changes. How the equation changes, you multiply the entire function by a number greater than 1 or less than -1. So it just has to be a number bigger than 1, less than -1. So in other words, it can't be 0 and it can't be a fraction. Okay, so now let's look at compressing vertically. So when we compress a function, all right, it widens, right? So it actually moves towards the x-axis. Those sides kind of move down like they're about to touch the x-axis and further away from the y-axis. Okay, so when we do that, the equation changes by multiplying the entire function by a fraction. So that's any number, decimal or a fraction, between 1 and -1 that isn't 0. Okay, so just like we went over, the study guide has the example of the parent function of a parabola x squared. So here's the normal graph of the parent function. If we're stretching vertically, you can stretch by, let's say 3. 3 is the number that we multiply out front, and you can see that it gets more narrow, further away from the x-axis and closer to the y-axis. If we multiply by a fraction like 1/3, you can see it's getting wider. It's getting closer to the x-axis, further away from the y-axis. All right. So next, we're talking about flipping. Okay, when you flip a graph of a function over the x-axis, over an axis, sorry, you change its location. Okay. So when we flip a function over either the x or the y-axis, you change its location. Again, you're not going to change its shape. Okay, so now let's look at flipping over the x-axis. When we take a function, let's say it looks like this, and we want to flip it over the x-axis, it's going to look like that, right? So if that's the case, then the y-coordinate changes signs. So if you take this y-coordinate, let's say that's 3, then down here it would be -3, right? And then if the equation changes, you multiply, I'm just going to write mult, that's all I have space for. You multiply the entire function by a negative number. And this is something that we already knew, right? Because if we're dealing with a parabola, this, let's say, is x squared, this would be -x squared, right? So if we multiply the entire function by a negative, if we have a negative out front, that's when it flips over the x-axis and kind of turns into an n instead of a u. So if we're looking at this cubic function here, it's a little bit harder to see what we're doing, but if we flip it over the x-axis, the y-coordinates switch, and it's just like you were reflecting over that x-axis. Now let's talk about flipping over the y-axis. If you flip over the y-axis, the x-coordinate changes sign. So let me draw a picture of that. I think it's easiest to see with a parabola. Actually, let's think. Yeah, let's do a parabola, but let's have it not centered on the y-axis. So if I flip that over the y-axis, it's going to look like this, right? So let's say that this x value is -2, this x value is going to be +2, okay? And so again, we multiply every x value in the function by a negative number. So when we flip over the x-axis, we're multiplying the entire function by the negative number. But if we flip over the y-axis, we're just multiplying the x value by a negative. So here's that equation. We're only multiplying the x value by that negative. The negative is not front, it's only on the x, so that's when you know you're flipping over the y-axis, okay? And so here's the picture of, here's a picture of that function. When we flipped it over the y-axis, you can see all the x values are going to be flipped. All right, so just the last part of our study guide for today. So here we're combining stretching and shifting in order to write new equations. So we have the parent function of a parabola, x squared. So it's stretched vertically, we multiply it by 4, and shifted 1 unit down, okay? So our new function, let's call it g of x, is going to be, if we stretch it vertically, we're multiplying by 4, then we have x squared, and we know if we shift 1 unit down with a vertical shift, it just goes on to the end of the function, all right? Next, again, parent function of a parabola is compressed vertically, so that means we're multiplying by a fraction. Remember, when we compress, it gets wider, so we multiply by a function. And then it's shifted 2 units to the left. Since this is a horizontal shift, remember we're going to have to put 2 inside of the parentheses, okay? So our new function g of x is going to be 0.5, and then in parentheses, remember we're shifting 2 units to the left. So remember, don't trust your x's. X plus 2 shifts us to the left, and then we have squared because it's a parabola. And that actually finishes up our video for today. This is a pretty short study guide. I hope this helped. And then remember, on Wednesday, I will be uploading the video for the checkup. So I hope this helped. Please let me know if you have any questions. Don't forget to do the quiz that I've assigned to you on Teams, and keep working hard on your Apex work. And have a great day.